Okay, I'm going to share the tune. So we have discussed up to parity check uh, from public switch telephone networks. I think we have to discuss from that part. Okay, public switch telephone networks mean nowadays we have broadband connections and all this stuff, but earlier we had something called dial-up connection. Dial-up connection. When we dial-up connections means it has the downloading and uploading speed is the same. Now we know download speed high, uploading is bit slow, but downloading is high. But in when you are talking about dial-up connection, uh, they have both the downloading uploading speed is the same, and the other thing is it has. I think I can remember like in the dial-up connection nowadays we are not using actually around 56 kilobits per second. Kilobits, very slow connection was there. And the other thing is you have to dial into the service provider's node. That means you have to take a phone call to the service provider's computer, right? So when you're using this dial-up connection, public switch telephone networking, it is like you have to pay for the internet as well as you have to pay for the telephone call charges even. So that is called public switch telephone network. Then we'll go to modulation and demodulation part. So modulation and demodulation mean modulating means you are uh, converting digital signal to analog, and the vice versa. Other side is called demodulation. So this is happening inside the modems. Now in our computers we have digital signals. These we discussed digital signals, analog signal last session. So in digital signal, what is happening? This what we have inside the computers are digital signals. So these digital signals are converting to analog and going through a telephone line. So other end, what is happening? Other end, the analog signal is coming inside the computer. So what it does, it converts this analog signal to digital. So this conversion, that is modulation and demodulation, is done by the modems. Now at the moment we are using ADSL routers and all that. So inside this ADSL routers, even we have this modem inside them. We have modems, but nowadays we are calling them routers. No, not the normal router. It's ADSL internet router. So it is inside that you have the this mechanism is happening. Then we'll go to topologies. Topologies means when you are taking topology means in a computer network how you are going to connect computers. How we are going to connect computers. So that is called topology. Topology, under topology we have point to point. Point to point means we'll go through that. Our two computers connecting by using a cable. Usually using a cable you are connecting two computers, right? So that is called point to point. So point to point network contains exactly two hosts such as computers, switches, routers or servers connected back to back using a single piece of cable. Often, the receiving end of one host is connected to sending end of the other end, vice versa. That means two computers are connected together. Two computers are connected together. Now, if you look at this tube, you can see here point to point connection here, right? So here two computers are connected together. Two computers are connected together. Uh, so what will happen? Only these two computers can share their resources, right? Then if you go to next one, bus topology. Bus topology consists of main run of cable with terminators at each end. All nodes, that is file server, workstation and peripherals, are connected to the linear cable access to the shared common communication medium by node. It's a problem when multiple nodes try to access the medium at the same time. Now, if you go to bus topology, I'll make it a bit larger. So in bus topology, these are the terminator. Here you have a terminator, here also you have a terminator. So this is the single cable. So to that cable, all these computers are connected. All these computers are connected. So there's a problem. When multiple nodes try to access the medium at the same time, that means now this computer is sending a data. I will take this one as A, and this is sending to data to B. So it is going through this cable like this. So while it is going, this will take C. C computer also want to send some data to the A. So he also sending some data. So what will happen? This can be collide or crash. So when it crash, your data or the whatever the packets, data packets will be destroyed. So that can happen. There is a problem when you're using the um, bus topology, but there are some mechanisms to avoid them. We are discussing them later, right? So this is called bus topology. So it is a common cable. If something happened to this cable, your whole network will be damaged. That means the whole network won't work. But if one computer is not working, suppose this computer is not working, but the other computers are working properly, so you can communicate, you can have the network even one computer. So in the bus net topology, so I am revising you. In bus topology, you can add or remove computers at any time without affecting to the other. But the common cable damage, whole network will be uh, in a, that means whole network won't work, right? Then if you go to star topology, star topology, here write down under that. Amandi, what happened to Lihini? Is she not coming today?
I don't know, sir.
Ah, okay, okay, right. Then we'll go to star topology. There I will write down. A star topology is designed with each node means the computer, each node is connected directly to a central network or central network hub or switch, central network hub or switch. We'll go to the topology and see how it works. Star topology. Here you have star topology. Now this is the central node. All the computers or nodes are connecting to that bar. So what will happen if one computer is not working? Nothing will happen. That means it won't affect to the network. But if something happen to what will happen if something happen to the central node? Suppose this is damage, so whole network won't work. You can't communicate with computers because central node is not working. So that can happen. So that is the disadvantage. But advantage is you can anytime you can add or remove a computer from the start topology. So that is a advantage. So usually in our computer labs and all that, we are using this topology. We are using this topology. No need to have the same way of connecting the computer. You can not like a star, even it is a star, right? So if there's a central node, that means definitely it is a star topology. Then මේ වගේ වුණත් අපිට connect කරන්න පුළුවන්. You can connect like this even. So this is our central node. To that node, all the computers are connected. Not like a star. Star එකක් විදිහටම වෙන්න ඕනේ. But it is also star topology. Why? Because you have a central node. Central node එකකට computers connect කරන්නේ star topology එකේ විතරයි. අපි tree එකේ පොඩ්ඩක් මේ වගේ එකක් තියෙනවා. I will explain that. But other than that, you should have a star topology to connect all these computers within a centralized node. Okay. Then we'll go to the other one. Ring topology. In a ring topology, each station is directly connected only to two of its neighbors. Message sent between two stations pass through all of the stations in between, clockwise or counterclockwise. We'll go to the ring topology here. Okay, this is the ring. So it is now, if you take this computer, what has happened? It is connecting to the neighbors. These are the two neighbors that it has. So when you take this computer, what will happen? It is also connecting to the neighbors, two neighbors, right? So this is how it works. But your data is going only one side. If it is going this way, it's called clockwise. If it is going to other side, that is called counterclockwise or anti-clockwise. But it is not going both direction. It is not going both. දෙපැත්තටම data transmit වෙන්නේ නැහැ. මෙයා මෙතන ළඟ හිටියා කියලා. මෙයාට මෙහෙම ටක් ගාලා යන්නේ නැහැ. ඒක යනවා නම් මේ පැත්තට නම් it goes to same way. So it's not going both ways, right? So that is called ring topology. But here the disadvantage is if one computer is not working. So if something happened to this computer, the whole network will be in damage. That means it won't work. Whole network will be not working. So that is the disadvantage. But advantage, when you are discussing the advantage, if you send a message to this one time, it will pass all the computers. But in this star topology, if you are sending a message, you have to directly send it to this one. It is not going to all the computers, right? If there's a hub only, it is happening. But here ring topology, it is going all the computers. Those who need to get the message only takes. Others, they are rejecting. So this is how ring topology is working. Then we'll check next one. Mesh topology. In this type of topology, a host is connected to one or multiple hosts. This topology has hosting point-to-point connection with every other host, or may also have hosts which are in point-to-point connection with few hosts only. That means they are connecting point-to-point. Now we discussed what is point-to-point. If we take mesh topology, now when this computer is connecting to all these computers point to point by using the point to point. So all the other computers also connect. So it's like a mesh. Connect. If you have more computers, it's like a real mesh, right? So that is how it is happening. So, but in this situation, in this topology, what's the disadvantage? You have to have more cables. Good cables use to connect the computers. So if one computer is not working, nothing will happen. Others are working properly, so they are connecting separately. Okay, so making a computer damage. Then I told you tree topology. So tree topology also has hierarchical topology. So nowadays we are using that other than this stuff in big companies and all that. This topology imitates as extended star topology and inherits properties of bus topology. So when you take star topology, you can see here, if you take this part, it's like a tree topology. But all these computers, this whatever the central node or whatever it is, connecting to a common cable. A cable connector. So when we consider about that part, it's like a bus topology. So tree topology means it's a combination of bus topology and star topology. So it's a combination of that. So that's why I told in this tree topology you have the centralized node if it is having star topologies also. Then we'll see the other one. Hybrid topology. A network structure whose design contain more than one topology is said to be hybrid topology. Hybrid topology inherits merits and demerits of all the incorporating topologies. So whatever merits, whatever the demerits will be coming to this hybrid topology, because in this hybrid topology you are connecting different types of topologies together. Here you have ring topology, then it's like a bus. Then star. Connect so whatever the topology they are connecting together. Take it again hybrid topology scale. Then we'll go to the switches and hub. So hub and switches are common network device that functions as a common connection point for network devices that make up a network. A switch receives data in one of its incoming connection and forward the data only on the outgoing connection, which connect to the destination device. A hub receives the data in one of its incoming connection and then shall forward the data to all of its outgoing connection. In this way, a switch is more intelligent device than a hub. Now, if I discuss them about a bit deep, I can tell something like this. If it is a hub, all these computers are connected through the hub. So what is happening when it is coming message from this computer to the hub? It is now suppose A, B, C, D. So a computer need to send a message or transmit data to the C. So when it is coming to the hub, what is happening? It is sending to all these computers. It is sending to all these computers. But what is happening? These computers are rejecting. So it is again coming this side. This is also rejected. This one only take that data. So that is how hub is using its technology. So it is called half duplex. Half duplex. Half duplex means one direction at a time. One direction at a time. That means if it is going to this direction, it is not coming. After going only, it is coming, right? But because of the hub, there's a unwanted traffic is generated. Traffic එකක් ඇති වෙනවා කියලා කියන්නේ. ඇයි ඒ traffic එකක් ඇති වෙන්නේ? මේකට ඕන නැති data එකක් going to that and is rejecting. Again coming this. So at that time, this route has a traffic. යාපු message එක නැත්නම් යාපු data එක again it is coming through that same route. So there's a traffic. Even this computer, suppose this computer want to connect to this one, cannot send. Why? Because there's an unwanted packet. Data packets are moving from here to here. After that only the B computer can send the data. So because of that, unwanted traffic is generated with the hub. Right? So So that's how it's happening. Other computers are rejecting. Only the computer that need to have the data will be taking that data, right? But if you are using a switch here, if you are using a switch here, so a computer need to send some data to the C. So it is directly going to that without going to these computers, without going to these computers. So we are telling switch is full duplex. At the same time, you can send and receive data at the same time. So switch is full duplex and it is intelligent. It is intelligent means what? It is sending it into the relevant computer only. So to identify computers, IP addresses, all this is stuff we needed. So we are discussing it later. But to identify, we need to have have to have IP address. Through the IP address, switch is identified correct destination, and it is going to that correct compute. So that's how happening. Hub and switch are working together. So we'll go to the tune. So then we'll go to the type of networks, different types of networks. Generally, networks are distinguished based on their geographical span. How that means how these computers are how spread. The uh, geographical area, geographical area actually, right? A network can be as small as distance between your mobile phone and its Bluetooth headphone, and as large as internet itself, covering the whole geographical world. Now, if you take a PAN, personal area network, there are different network types. Personal area network is like a square meter. Usually, your computer and the mobile phone, or your mobile phone and the headset. So that can be a personal area network. If you consider about LAN, local area network, that is coming under around 10 meter to 100 meters or 1 kilometer even can happen now. Room, building, campus, even you can have local area networks. In campus, there are something called campus area network also available. But don't worry about those stuff because it's not in the syllabus. Then you will be confusing what is this CAN and all this stuff. But LAN, FAN, MAN, WAN, those things you have to understand, right? There are different types. But the whatever the network is based on the geographical span, geographical area, right? So when you take the metropolitan area network, it contains around 10 kilometer to 16 even, up to 16 kilometer even, it has spread. Now if you take two cities, Gampaha and Kadal, something like that, can be have a metropolitan area network. Then wide area networks, it has spread all over the world. So what is internet is the best example for the wide area network, 100 kilometer, 1000 kilometers. So country wise, you have the this type of network. So that is called wide area network. Then we'll continue to broadcast and unicast of message. Broadcast and unicast of message. So broadcast of message involves sending a message to large set of recipients, whereas unicast data is sent from one computer to another computer by including the unique address of the recipient in the message itself. Now, if you take, you have unicast, broadcast, and you have multicast also. I will explain that. Unicast means now here you can write an example sending a SMS. Here put example sending a SMS. So one person is sending SMS to another person. So that is called unicast. එක්කෙනගෙන් තව එක්කෙනෙකුට යන data එකක් වුණොත් එහෙම, right? Sending message. Now multicast means multicast කියන්නේ when you are sending message, you are sending to group of people. Now in our WhatsApp group, I send a message that you have class at 8 o'clock today. So I am sending only our group, only to our group, right? So this, but several members are there. So you can put example sending a WhatsApp group message. So it's like multicasting. Then broadcasting. Broadcasting means you are sending your data to everyone. Those who need, they are taking. Those who not need, they are not taking. But you are sending everyone. You are sending everyone. You are not sending your message to everyone, right? But what is the best example? Cut the example. Radio broadcasting. Radio broadcasting මොකද වෙන්නේ? ඒ channel එක ඔක්කොටම broadcast. Those who need, they are uh, finding the channel and they are listening. Telecasting also same thing. So you can put an example, radio broadcasting. So that is called one to all. One to one, one to all, and one to several. So those are broadcasting, multicasting, and unicasting message. Then we'll go to the some types of protocols. Kind of protocols are there: Aloha, slotted Aloha, and Ethernet. So Aloha, when you take Aloha, pure Aloha, something called pure Aloha. Now these things we are using to transmit data without crashing or without damage. So we use this kind of technology to send data or transmit data through network without damaging them, right? So pure Aloha, what is happening? It allows the station to transmit data at any time whenever they want. After transmitting the data packet, the station wait for some time. Now, case one, so they are sending a data. Now, suppose from A to B, it is sending data A to B. So, case one, transmitting station receives an acknowledgement from the receiving station. In this case, transmission station assumes that the transmission is successful. Now I am sending a message. I send a message that you have a class. One student has put a message. Okay, sir. Then I got the acknowledgement. I got the acknowledgement. So I know that. Or we can we can go to read by in the WhatsApp. We can check whether you have seen it or not. So that is the acknowledgement. So when I get the acknowledgement, I don't want to send it again. In case two, in pure Aloha, that means in pure Aloha, even though you are sending a message, if you are getting acknowledgement that it thinks okay. Now from a computer A to computer B, it is sending some data. So what is happening in computer B from B? You are getting a acknowledgement to the computer A. So computer A knows that okay, this transmission is successful. He is not going to send it again. Case 2, transmitting station does not receive any acknowledgement. So if it is not receiving any acknowledgement within the specified time from the receiving station, in this case, transmitting station assumes that the transmission is unsuccessful. Now, there's a specified time. Specified time is there, suppose within 10 seconds, 20 seconds. Within that time period, if you don't get the acknowledgement, it thinks, okay, this transmission is unsuccessful. So that is the method of pure Aloha. When you go to the flowchart of that one, flowchart, don't worry about this flowchart. Flowcharts are now, I think you have done in theory classes, you have done Python and all that. In that Python, you have this flowchart pseudocode stuff. So I think you can understand this flowchart part. So what is happening? I start, then set back off to 0. That means a kind of a assignment, that is a variable. It's set to 0. Send the data packet. Sending the data packet. Then waiting. If it is receive acknowledgement, if it is yes, then it is successful. No need to send data. That the sender knows, okay, this packet has gone to the correct destination. That's successful because he is getting the acknowledgement. ACK means acknowledgement. If the acknowledgement is not received, increment back off. So this back off will be increased by 1. Now suppose as example, when you are taking the money from the ATM, when you are taking money from the ATM, you can put your PIN numbers, you can insert your PIN numbers 3 times. If you try, that means if you are making if you make any error of the PIN, entering PIN, it gives 3 times. After that, it will take the card and it will lock. You can't take the card, right? Same thing. That's how it identify whether you have tried 3 times by using this kind of a setback variable. So increment by 1. Now suppose setback is 0 at the beginning. So increment back off means it become 1. Now reaching limit. Now limit also given. Say we'll take 3. Reach limit. No. Wait back off time. So again send the data. Again waiting, receive, again increment, that means 2, like that. When it comes to 3, what will happen? They reach the limit, yes. After yes, it will abort. So that means it's trying to send data several times. If it is failed, it will abort. That means it won't send the data again. So that kind of thing happen in pure Aloha. Then we'll go to slotted Aloha. Look at here, slotted Aloha. Divide the time of shared channel into discrete intervals called time slot. So here it is dividing the shared channel into discrete intervals called as time slot. Any station can transmit its data in any time slot. So suppose we have time slot 5 තියෙනවා කියලා 1 2 3 4 5 කියලා තියෙනවා. 5කට බෙදලා තියෙනවා. එතකොට ඕන එකට you can send the data. The only condition is that the station must start its transmission from the beginning of the time slot. අපි තම time slot එක තප්පර 10යි කියලා 10 second. ඒකට time slot 5කට හදලා තියෙනවා. ඒතකොට time slot එක පටන් ගන්නදී when it is starting your first second එකේ ඉඳන් 10 second වෙනකන් යනවා. ඒකෙදී first second එකේදී at the very first second you have to start your transmission. That is the rule. What බැරි වුණත් කරගන්න, you have to wait for the other time slot. If the beginning of the slot is missed, then station has to wait until the beginning of the next time slot. Now දෙවන time slot එකේ පටන් ගන්නකම් එයාට ඉන්න වෙනවා. If he couldn't start the transmitting data, it's a given time slot. Suppose if there are 5 time slots, each time you have to wait until you get the chance, right? A collision may occur if 2 or more stations try to transmit data at the beginning of the same time slot. දැන් මෙහෙම අපි පාරක් තියෙනවා. So one car can move at a time. එක කාර් එකටයි move වෙන්න පුළුවන්. මෙයා අපි તો මෙතන ගේ තියෙනවා කියලා. හරිද? මෙතනත් මෙයා ගේ තියෙනවා. මෙයා කාර් එක කොහොම දාද්දිම අරයන් මොකද ගන්නෙ? Is also coming. එයාත් මේ පැත්තට එනවා. අරයා දානවා බලන් ඉඳලා මෙයාත් දානවා. දැන් මොකද වෙන්නේ? දෙන්නම ආව මැදට ඩෝන් ගාලා හැප්පෙනවා. Right? So they can't move, right? දෙන්නටම යන්න බෑ. Right? So someone has to reverse. It can reverse කරලා ගන්න වෙනවා. But in data transmission, your data packets cannot reverse. ඒගොල්ලෝ දැක්කම ටක් ගාලා reverse කරගෙන යන්නේ නැහැ. So what will happen? These are coming, data packets are coming and they are collide වෙලා collision may occur. So the data transmission, data packets destroyed. So your transmission won't happen, right? So this can happen in this slotted allow. Right? අපි එකම time slot එකේ time slot 1 එකේ if both are starting at the same time, then there will be a pop. So that is called slotted allow. Slotted allow. If you go to Ethernet, allow multiple access common shared medium with the use of CSMA and CD. There are techniques to use without having collision. You can use the same or common shared medium without collision. So by using the CSMA or CD technology. Sensing the carrier under that, write down step 1. Any station willing to transmit data sends the
Sorry, sir.
carrier. Any station willing to transmit the data senses the carrier. If it finds carrier free, it starts transmitting its data packet. Otherwise not. I will explain it. We'll go to this how it happens. Each station can sense the carrier only at its point of contact with the carrier. It is not possible for any station to sense the entire carrier. Thus, there's a huge possibility that station might sense the carrier free even when it is actually not. Now, if you go through this bus topology thing, now here computer A, node A, point of contact for station A. So he's checking only this part whether there's a data. C is checking here. B also checking here. D also checking here. But when B is checking here, he can't check here under C. So he's sending some data. So there can be a possibility that data is coming from D. So it can be collision. But there are CSMA and CD techniques, kind of thing called token ring also there. So when you're using token ring, that means you are sending a small token. Token is kind of a data packet. Suppose the data packet, it is going through this line. Right? If something happen, it is collided, then it is not coming. If there's no data on this media, again it is coming to here. Then computer A can understand there's no data transmitting in this common media. Then he start transmitting the data. Right? Then he start transmitting data. So that kind of technology techniques are using in CSMA and CD, that is a collision detector technologies are using. Otherwise, now this kind of thing also can happen. That point A is detecting point A part only, but cannot detect the other parts. So if there are some data, he think there's no data passing this one, he's sending data. So there can be collision can happen, right? But nowadays there are techniques, as I explained earlier, to detect whether there is a data or not. If it is not there, only send in the data. So collision has eliminated or reduced nowadays with these technologies or techniques. Then if station A sends the carrier its point of contact, then it will find the carrier free, but the carrier is actually not free because station D is already that's the same thing what I discussed, already transmitting its data. If station A start transmitting its data now, then it might lead to collision with the data transmitted by station D. So that can happen. So when you are detecting the collision in CSMA CD, this responsibility of the transmission station to detect the collision. For detecting the collision, CSMA CD implement the following conditions. That's condition is followed by each station. That's what I told about token ring, right? So using this token ring, this kind of condition, it detect the deletion, it detect the collision. Or even this data, that collision, after detecting the collision, he can send the data again. If something happened, that means now it is trying to send data without collision. If something happened, that means collision is happened, it is sending the data again because it can detect the collision. අපිට එයාට පුළුවන් collision එකක් වුණා කියලා අඳුර ගන්න. දැන් මම ඔයගලන්ට message එකක් යවනවා. ඔයගලන්ට ඒක ගියේ නෑ කියලා මම දැනගත්තොත් මට ආපහු එවන්න පුළුවන්. So data transmission can be complete. But if I don't know whether it's received or not, that means I can't detect. එහෙම වුණොත් තමන් හිතන් ඉන්නවා ඇවිල්ලා කියලා ඔයගලන්ට ඒක ඇවිල්ලා නැහැ. ඒ වගේ දේවල් වෙන්න පුළුවන්. So in this CSMA CD it can detect the collision. collision එක නැතුව යවන්න try කරනවා detect කරන්නත් පුළුවන්. collision එකක් වුණොත් එයා detect කරලා can send the data packets again, right? Then we go to the multiplexing. Write down there. Multiplexing is a technique by which different analog and digital streams of transmission can be simultaneously processed. Yes, I'll repeat. Multiplexing is a technique by which different analog and different analog and digital streams of transmission can be simultaneously processed over a shared link multiplexing divides the high capacity medium into low capacity logical medium, low capacity logical medium, which is then shared by different streams. Right? So I will explain this what is called this multiplexing. Now, in our, if I take fiber lines, our fiber lines, we have telephone line, data, JPOT. These three different things are coming through one cable line. Right? We don't have separate cable for the telephone, data, POT. We have a cable. We are getting one cable. So how this data identify whether it's a telephone call, whether it's a data, or whether it's a POTV signal? So that is done by the splitter or the router we have with the fiber line, right? So in this splitter, it is identified whether this data related to telephone call, whether it's related to data that is for the internet, or whether this is for the TV. So how it is identified? So this multiplexing means you are sending three different signals in the same cable. So that is called multiplexing. So when it is multiplexing, there should be a mechanism to identify separately for each signal. Right? So here in the tube, you can see you have frequency division multiplexing, time division multiplexing, and code division multiplexing is given. That means in one cable, all this data is coming. As an example, I am taking example. If this telephone is coming 100 hertz, I am taking example. This is not the real frequencies. Right? This is coming 200. This is coming 300. Right? So if the splitter can identify this frequency division multiplexing part, it can send data. Now in the splitter of the router, we have three cables connected to this one, splitter of the router. So this part can understand, okay, this is coming with 100 hertz, I have to send to the telephone line. If it is coming 200, that is 200 hertz, I have to send it to the data line. If it is 300, I have to send to the PO. So if this mechanism is happening inside this splitter of the router, nothing, then no problem. That means it's not mixing. It is not mixing. So all the signals can be separated for the telephone, the internet, or the POT, right? So this is called frequency division multiplexing. So it is taking frequency to separate this signal. If it is time division multiplexing, time slots they are using to separate these signals. If it is code division multiplexing, kind of a code. Now telephone T, code T, that I'm just telling to like get your giving you an idea about this, right? Then data D, your DP. This kind of a code also attached to the data. Code means everything in the signal. Code means you can't send the letters and all that. Whatever it is, it should be a signal that is ones and zero, digital or analog signal, right? Current, actually current, right? Electricity current can be a signal, right? So whatever this code, say T is represented with something, D is represented with something, B is represented with another signal, right? So these signals embedded and sending. Then if it is a code division multiplexing, by checking the code, it is sending the data to the relevant telephone, internet or POTV lines. So this is called multiplexing. This is the basic idea of multiplexing. We'll go through the tube. Get back to the tube. So I have given frequency division multiplexing. We'll read that. When the carrier is frequency, FDM is used. FDM is an analog technology. Divide the spectrum or carrier bandwidth in logical channels. Logical means it's not dividing physically. Logical it's dividing. Right? And allocate one user to each channel. Each user can use the channel frequency independently and has exclusive access for it. Time division is applied to primarily on digital signal, but can be applied on analog signal as well. In TDM, the shared channel is divided among its user by means of time slot. Each user can transmit data within the provided time slot only. Time slot I can remember. I think you can remember time slot we discussed earlier also. So same kind of time slot can be used here also. So in the given time slot only it can send the data. Then CDM, code division multiplexing, multiple data signals can be transmitted over the single frequency by using the code division multiplexing. FDM divides the frequency in smaller channel, but CDM allows its users to full bandwidth and transmit signals all the time using a unique code. Now, the difference in the frequency division multiplexing, it is dividing. So, three roads. අපි හිතමු ලොකු පාරක් තියෙනවා. මේ පාරේ මෙන්න මේකට යන්න පුළුවන්, මෙන්න අනිත් එකට යන්න පුළුවන් කියලා අපි වෙන් කරගන්නවා. Frequency division multiplexing නා මේ පාරේ යන්න පුළුවන් telephone. This is data. This is UTV. ඔයගේ වෙන් කරගන්න. The whole road එකේ bit එක ඔන්න ඔච්චරක් තියෙනවා. But in CDM මේ මුළු road එකම නැත්තම් මේ bandwidth එකම use කරන්න පුළුවන් එයාගේ data යද්දි. මොකද frequency එක වගේ separate කරන්න ඕනේ නැහැ. We are sending the data by attaching a code. එතකොට මේ code එකක් attach කරලා මේ full bandwidth එකම use කරලා අපිට data යවන්න පුළුවන්. Right? So that is called CDM. That is code division multiplexing. Okay. We'll go to the networking devices. Networking devices, when you are taking networking devices, network interface cards are there. A network interface card means the interface card we are using in our computers to connect the computers to our networks. Network switch and hub I discussed earlier. The router, we are using router to connect one network with another network. That means our home network, we are connecting to the internet. So we are using routers. So two different networks are connecting together. Then bridge. Now bridge is used to connect same type of network or same network. Now suppose we can't handle the like large networks, or we can't manage them properly when it is the number of computers are large. So we are using bridge to connect the same network. We are bridging, or we are separating two networks, and you are connecting those two again with a bridge. Then repeaters, why we are using repeaters? Now our signals. Now suppose we have Wi-Fi. Say in a 5-story building, we have Wi-Fi facility. So in the first floor, we are having the Wi-Fi router and all that. But when it is coming to second floor and third floor, we can't have the signals. It's not, we don't get the signals. So what is happening? We can fix this kind of a repeater in the say second floor or first floor where you get the signal. From that place, it is regenerating your signal. It is regenerating your signal, and again it is sending the Wi-Fi signal. So you can go to third floor even. So repeaters can be used if the signals are have less strength. You can have a repeater to connect those or use that signal in a distance place even. Then multi-layer switch. This multi-layer switch is like a router also. It works like a switch as well as router also. That means we can use them to connect to the internet even. Right now, usually switch and hub we can use connect computers together. But multi-layer switch we can use it to connect to another network even. Not only connecting computers together, you can use it to connect to another network even. Then you have firewall. Firewall we used to avoid or to restrict users which are not allowed to come to our network. We can use this firewall to prevent unauthorized access. Unauthorized people are trying to access our network. That can be eliminated by using firewall. Use කළා අපිට protection එකක් දෙනවා. Gateway also can be used to connect one network to another, but two different hardware components. That means suppose you are using Office, Microsoft network, you have another network, you have Linux or Red Hat Linux kind of network. So two different networks can be connected by using a gateway. So those are the networking devices. We'll go to network testing method. I will share this command prompt to check these commands. Okay, right? So I think you can see my command prompt. Okay, first command is ipconfig. Now I am typing ipconfig here. Now look at the result. I am getting my IP address. Now IP address part we are going to discuss later. So this is my IP address, right? This is the IP address. This is called subnet mask. You don't sometimes you have idea because you have done this theory part. This is the default gateway. Now, if I want to check my IP address in my computer or any other device, you can use ipconfig command. Ipconfig command. So it is giving the IP address of the device. IP address of the device. And the subnet mask, it is related to network classes and all that. So we are going to discuss it later. And default gateway. Gateway is the place where I am going out, going outside. That means if I am going to internet, I am going out through this gateway, default gateway. So my default gateway is 192.168.1.1. That means I am using a fiber line telecom line. So that's why I am getting this IP address 192.168.1.1. I think telecom SLT they are giving this IP address. If you are using dialog, I think I can remember 192.168.1.8 is the gateway address. That means the router address. Actually, this is the router address of my connection. So this is default. So these things can be checked by using the IP config. IP config. So in the tut you can write under IP config. Yes, IP config command is given. Under that, write down here. This is used to check your device IP address. Check your device IP address. Subnet mask and default gateway address. Okay, then we'll see IP config goal. IP config goal. Again, I'm sharing the command prompt. I'll put IP. First, I'm using CLS, that is clear the screen. Then IP config slash. Oh. So I think you can see other than the IP addresses, other than my IP addresses, you will be getting DHCP server address, DNS domain name server address, and the physical address means the MAC address. So all this stuff can be seen other than this subnet mask, IP address and all that. You are getting these things all, right? So DHCP server means now these IP addresses are given by automatically, not assigned. So automatically IP addresses are given by using the DHCP server. DHCP server, right? Then DNS means domain name server. So when you are typing your web addresses, it is converted to IP address by using the DNS server. Then you have physical address is the MAC address. MAC address, it is not changing. This address is not changing. It is permanent for the device. So this is called physical address. So those things can be seen by using this IP config all. We'll write down there. IP config all, there write down. Other than the above details, DHCP server, DNS server and physical address, or within bracket put MAC address. MAC can be seen. Then we'll go to the ping command. I'll show you how it works. Now I am using this ping command to connect it to another computer. Now I know that my router IP address, so I am using 192.168.1.com. That means I am sending some data packets to this router, and I am waiting for receiving them. Right now here you can see I have sent 4 data packets and I am receiving 4. So my loss is 0. That means I can connect to my router without any problem. Now here the main thing is given round trip time. RTP, round trip time is the time it used to send the data packet and receive. The time it takes to send and receive the data packet. So minimum time has taken 5 millisecond. This is in millisecond. අපරෙන් 10න් එකක් millisecond එකක් කියන්නේ. It's a very small time. Then maximum 10. So average is 6. Data packet අතර ගිහිල්ලා එන්න average time එක ගිහිල්ලා එන්න round trip time කියන්නේ ගිහිල්ලා එන්න ආපහු. So 6 millisecond has taken. And here you have TTL. TTL means time to live. Time to live can be data packet එකට ජීවත් වෙන්න තියෙන කාලය. So if it is exceeded, it will destroy the data packet. ඉතින් ඔන්න ඔය time ටිකක් පොඩ්ඩක් මතක තියාගන්න ඕනේ. I am using another say we take another IP address. I can't remember the IP address, so I am thinking to the Google. මෙහෙම දෙනවා. So Google, it automatically find the IP address of that, because I don't know the IP address of Google, so I just gave the google.lk web address. So it is taken automatically and checking how many are. See, sent 4, received 4, lost 0. That means there's no problem. I can connect it to the Google server without any problem. But here, minimum and maximum, your average millisecond is greater than this one. So this is my router. It is close by, but this is it's a far away place maybe. So it takes, but it is 42 millisecond. It is not a second even. It is not a second even, right? So this is how you can check by using the ping command. By using the ping command, you can check whether your devices are connected properly. Now, suppose your computer networking is not working, can't go to internet. First thing you can check is you can check yourself. That means I will show you. You can check before you check the router. Even you can check yourself. That means ping 127.0.0.1. So this is pinging means you are sending and receiving data packet on your own network card or network device, your own network device. So that's why this minimum maximum 0. The same place you are pinging. That means same device you are pinging. So that's why your time is making as 0. Right? So your lost also 0. That is working. Then you can check the router. Then you can check whatever the website. Then you can identify where's the problem, why you can't access or why you can't connect to that specific website. So they are write down under ping command can use to check the device, can use to check the connection between two devices. Check the connection between two devices. Then next one is NS lookup. NS lookup used to check the IP address. Now I don't know the Google IP address, so what I am doing, NS lookup www.google.lk. So I can get the IP address 172.217.194.94. So you are getting the IPv6 address also given. IPv6 address also given here, and this is IPv4 address. I'll check another one. NS lookup www.facebook.com. So that is 157.240.7.35. So I can without using the www.facebook.com address, if I type 157.240.7.35 even, you can access to the Facebook. So this NS lookup is used to check the IP address of a given web address. So write down there under this NS lookup thing. Can check the IP address. Can check the IP address for a given URL. for a given URL. For a given URL or the web address, you can put within bracket web address. Then we'll see trace RT. Trace RT. Now this trace RT is used to trace the path to a given server. Now I am using this trace RT to connect www. I can't remember the IP address. If you can remember the IP address, you can give it at once. Otherwise, I can give the web address even. We'll see how it trace, how it is connecting to the Google LK. What are the servers? What are the routers they have to pass? You see. So at the very first time, it's showing tracing route to www. It's taking the web address 74.124.200.94. Then it is over maximum 30 hops. Now 1, 2 like that, it goes up to maximum 30. So maximum hops is 30. Within this 30, if we can find the route, it will show, otherwise it won't. We'll see. It's finding the destination. Still going. This timeout also coming because the given time, if it is cannot connect, it shows as a timeout period. And again trying to connect. There may be a problem at the time they are going to connect. That's why we are getting requested timeout. Okay, so finally you got that. Finally you got that. So 72, 4, 125, 206, same thing, right? So after 24th one, you got the place. That means after timeout several times, it is connecting to the given web address or the server. Actually, it's server, right? So this is the root. This is the root. Now you can see this is a kind of same server or same this routers are using. Here it's changing. Like you can, this is the root or the path, right? They are write down under trace RT. Can find the root or the path. Can find the root or the path for a given web address. For a given web address or server. For a given web address or server. Then we'll see get MAC. I put this one get MAC. It will show the physical address of my network card. Now here media disconnected. Here device address is given 68 EC C5 33 2D and 4F. This is my physical address. Other two are disconnected. So at the moment I am using this is the MAC address of my device. So write down there. Can use to get the MAC address. Can use to get the MAC address of a given device. Okay, now we have IP addressing thing. We'll start that part on next week because now some of them